Hey everyone, this is Benjamin. I have a small project I want to share with you. Basically, how to build your own wind turbine. Now on the first part, we had a look at the project, an overview, at the schematics here. We also looked at what a propeller is and what a windmill or wind turbine is composed of. We covered some of the theoretical basics, the foundations, and also in particular the minimal induced loss design point. And finally, I showed you how to actually design your windmill in this program called XROTOR. And now for the second part, the fun part. Let's actually design this rotor on the computer, then print it, build it, test it, and have fun. Now we will design our windmill using this software called OnShape. You are able to open also my model here, and I will link it in the description. Now OnShape is great. I really love this tool. I'm gonna give you a short tour how to design this part. You see it kind of looks amazing. I really like it. Let's roll back to the very front. Basically I started with a very simple sketch, where's forward, where's the baseline, and then the blade design is done by the following. Let's activate all the planes. You have this plane. Now we will offset a plane to the right, which is where our first section will be. And on this we will generate a sketch. This is part of the sketch. Which you can see here. It's basically just a line which has the right length and the right angle. If we go into the sketch, you can see the first profile section here has a length of 150 millimeters, an angle of around 39 or 40 degrees. And then we can use this tool called Profile Generator. It's available. It's basically a script, and you can select your airfoil. Here we go for an Althaus windmill blade. It's probably not meant for the small scale wind turbines, but it's still a good choice if you look at the profile data. Alright, and now we repeat this for basically all the other sections, and I think we have around 10 sections. I'm gonna roll to here, and then you can see all these different sections. I'm going to show these real quick, and there we are. We have all these different sections in here. Okay, this is great. Now let's continue. Now that you have all these sections, you want to actually loft them, and what you can do is to get these 3D spline fits and select all these different elements. Okay, now you have these two splines, and then all you need to do is to loft this. You select the first really tiny small cord or airfoil here, and then you loft, and well, you can loft the surface, but I think a solid is better. And let's actually get a section view. This is always nice. Section view, and now you can really see how, let's get all the planes out. You can really see how this has been nicely lofted from the first profile all the way to the tip. and this is what we wanted. Now we need to find a way how to generate this middle section where actually the generator will attach to, and also what we want to do is to insert some carbon rods in order for the radial forces to be taken up by these. Okay, I'm not going through the details. As I said, you can have a look at this project yourself. This is the hub, nothing too big. I really went onto a full circle. Now we have one half of the blade done. The other half is just generated by mirroring the whole thing. I want to show you also how these reinforcements are basically included in the print. As you can see here, I have subtracted these holes or these rods from the main body, and then later, if you add a little bit of tolerance, you can just slide in and glue in these carbon rods into the structure, and they will take the main loads, and the print will basically just distribute the aerodynamic forces back onto these rods. This is at least the idea. We want to cut out the parts here. You can see the generator fits in here. We can activate the generator itself. This is how it will fit in, and eventually we can split this whole thing into different sections, as you can see here. Yeah, this is the final design of the rotor. I really like it. It's great. And then let's go on to the building process. Yeah, and fabricate this on a 3D printer. This is the first time we got this together, and it looks good so far. It looks amazing. Empty. This is just an amp meter, so we know how much current is actually flowing from the motor, which is used as a generator, down these motor wires into this little electronic box. And what's in here is the following. We have this is an electronic speed control ESC, which can do reverse current. So it can basically take energy from the system, convert it into DC, and then send it to the battery. It's not meant for long power sessions, but let's see if it holds through. This is a small microcontroller, basically just to gather data and to control the speed of the generator. And this is about it. even though we have pretty solid wind, this is still stalled, the whole thing, and it's not really picking up speed. It's good. We're actually generating some current here. It's great. I feel safe. The amps we are generating, so this is now 0.8. If I let it run a little faster, you can see, well, right now the wind is low. Anyways, this is giving us the amps, it's feeding it into the battery. The battery seems to be okay. This is the controller. Oh, now the wind is picking up. It's actually quite stormy. You see 1.7, now it's back to 1. Electricity, and it even works with much stronger winds than expected. And now we need to analyze the data. So, at least in the second try, it was a success. And it was on 18% before. Let's see where it's now. It's on 31. So we charged about 10%. Well, no, 13% into this battery. Pretty nice. Alright, let's analyze some data. The most important values were written, logged onto an SD card, and you can see all these files here corresponding to 5 minutes of each test. Now let's load some data and let's have a look on what is actually going on there. So what you see here now is the commanded throttle signal to the ESC, to this controller, speed controller. Okay, let's look at the RPM and see what happened there. And we see here that in the beginning we have a lot of noise, basically. So let's zoom in and try to understand what's going on here. Okay. Now, what the controller, this is all from the controller directly, telemetry logged in this Teensy controller on the SD card with 50 Hertz. And what you can see here is that the RPM are around starting at 200 going until maybe 600 RPMs. And 600 is what we designed it for. So we actually not spinning up because I was afraid to break it. Anyways, and then you can see these spikes, which are in the beginning when the whole rotor starts to turn. The motor actually, the controller actually doesn't really understand what's going on there, and so we have a low, or we have a wrong interpretation of the speed. But that shouldn't bother us. Okay. Let's have a look at the temperature. It's probably interesting. This is the temperature of the controller. I just want to make sure it doesn't get too hot. So this is a 5-minute log, and we start out at a temperature of around 25 to 30 degrees. And then because the controller needs to convert this AC current, into to charge the battery, of course there will be some losses, and this will dissipate as heat. And you can see here how the temperature slowly rises. Again, this is 5 minutes. I believe it will flatten out somewhere, but yeah, so this is still fine. We have a temperature of maximally around 45-46 degrees here. Actually, let's have a look at one of the later samples, maybe at the number 5. And here we go. Actually, we see we have reached much higher speeds here. Of course, I wanted to plot not the RPM of 1, but of 5. And here we see that we actually got some better logs of the RPM. You can see here we peaked at around 800 RPMs. It would be really nice to have the current as well, but the controller doesn't handle negative, or it can't measure negative current. I will add a sensor soon, and then we can have the actual power output, which would be more interesting. But you can see we got around 800 RPMs. This is good. It's holding up still. Let's actually look at the degrees, and you can see it kind of got hot. So we have around 65 degrees. I think this is still okay, but a heatsink or a whole different setup would maybe be better for especially higher powers. Okay, let's actually look what radial acceleration we will have at a RPM of, what is this, almost 800. That would be interesting. Now I've compiled this small script which can calculate the centrifugal acceleration and force. And now if we calculate this with the inputs, a mass of around 0.17 kilograms for one blade, and a radius, this is where the center of mass can be assumed. It's not exact, but it should give a rough number. And then the maximal speed here, omega max, for the angular velocity or speed. And if we run this, we actually get some quite high numbers. So the acceleration is around 1,800 meters per second squared, or 180 Gs, which is crazy. Yeah, only spinning 800 RPMs. And then here we have the centrifugal force on one blade is around 300 newtons, corresponding to around 30 kilograms of weight force on Earth, or for the two blades around 600, corresponding to around 60 kilograms here. So this thing needs to hold up a lot. Actually, in the first test, the blade didn't hold because it wasn't glued well. So this is really important, and probably for the next version I would add a bigger spar, a bigger carbon rod in there, just to get all the forces off in the right way. Just a short notice here, if you want to actually also build such a system and want to use my code, you are welcome to do this. I have linked this in the description. This is the project on GitHub, and there are all the files you need to run on your Teensy controller. I also included some telemetry and the scripts to load these if you want to use these. And you can see here I also described basically what this is for, and the electronics, how to wire up your system. I hope this is kind of clear, and also what the program does mainly and where I got some of the code from. Yeah, so you're welcome to use this, and please send me a picture or a video if yours is running. I would be very happy. Alright, hope you had fun watching this. Please subscribe, and let me know in the comments what kind of aspect you would like to have more information on, maybe how to design, how to use this program called XROTOR, or how to slice and print these things, or maybe how to develop the electronics. Anyways, hope you liked it. See you later. Bye. Don't run beside me. A little bit more, yeah.